Hello class, welcome to our lesson today dealing with section 5.2, which deals with proportions. Today we're just going to kind of look at a few specific applications of proportions, and then in our next class period we'll get down to the mathematical principles that are required to make sure for understanding of proportions. First thing that we want to deal with is you want to make sure you're able to simplify your fractions. So we've talked about this a little bit before. Remember some of your divisibility rules. For example, if they're both even, they're divisible by 2. If the digits add up to a multiple of 3, then it's divisible by 3. Obviously, 5 and 10 have their own divisibility rules as well. If you don't think something simplifies, my suggestion may be to try 7. 7 seems to be one that shows up a decent amount of time that you don't realize that it's divisible. Just some things to think about as you're looking at those questions. Here are the answers to all of these. Realize writing the fraction in simplest form, they can still be improper. Obviously, when we get to rates and ratios and proportions, it's okay that that fraction is improper because they have labels. So it'd be, for example, this may be 4 cats to 3 dogs, something like that. And so it's okay that those are improper as a final answer as we're looking at those situations. Okay, the next thing we're going to talk about is just seeing if two things are proportionally the same or the ratios are equivalent. That's the same reasoning in both cases. So for this one, it says it's $5 for 2 boxes of popcorn or $7.50 for 3. Essentially, if you find the unit rate of these two things and just divide them out, so 5 divided by 2 would be $2.50 per box, and $7.50 divided by 3 would also be $2.50 per box. If you just find the unit rate, you'll see if they're the same or not. And so in this case, they're both the same. The next one, 3.5 hours to drive 175 miles. Remember for this scenario that you want to put always miles per hour. You don't want hours per mile, okay, in most of these questions. So put the time on the bottom. And when you take 175 divided by 3.5, you get 50 miles per hour. 200 divided by 5 would be 40 miles per hour. Let's say if they're not equivalent, change the next day. So the next day is the 5 hours. So we got to change that 5 hours to 4 because we want this unit rate to be 50. So that'd be 200 divided by 4 then, to make it be the same exact miles per hour. On this next one, it could be calories per mile or miles per calorie. Probably calories per mile because you're going to say how far you're walking every mile. 300 divided by 4 would be 75 calories per mile. If you take 250 divided by 3 1/3, now this is where a lot of you are struggling with questions like this. Many of you want to take 3 1/3 and make it 3.33 and plug it into your calculator. You need to make sure you understand how to deal with this fraction as a mixed number into improper, make it 10/3. Keep, change, flip, make it 3/10. The 10 and the 10 and the 250 simplify down, and it's 25 times 3, which is 75 calories per mile. On that scenario, you want to make sure that you're able to deal with that correctly. So the expectation is that you can show this work here at the bottom of this page in order to be successful on those questions. Next one, 150 square feet in 2.5 hours. So that's like painting an area or a wall or something. It'd be 60 square feet an hour if you divide that out. 200 over 4 would be 50 square feet per hour. Honestly, the easiest option for this is to use the unit rate of the other one. Because you say, well, I don't know how to make it 60. Well, if you take 200 divided by the 60, it's like working backwards to find the answer. So if I take the 200 square feet divided by 60 square feet per hour, that'll get me 10 over 3 hours as a final answer, or 3 1/3, or 3 hours and 20 minutes. So if you have to work backwards to find it, just use the unit rate that's given and then divide that out to figure out the other piece of the ratio that you're trying to make equivalent. The next set of questions just talks about if something's fair. So if you find the unit rate of both, that's probably the easiest way to conclude if something's fair or not. This first one ends up being $92 a ticket when you divide out. This one's $88.67. The question of fairness, it might depend on the situation. So just per ticket, it seems like the one's cheaper than the other. However, maybe there's a set fee involved with the purchase, and it doesn't matter how many tickets you buy. So really, that piece may be offset a little bit. So you probably have to look a little bit closer into its fairness. And as long as you can explain your reasoning, then that would be fine. Obviously, not every reasoning is sound mathematics, but there are certain cases where both options may be correct. And this would be a good example of it. So is it fair price-wise? Not necessarily, because one is charging less per ticket than the other. However, in this case, maybe it actually costs a little bit more to actually get the tickets run through the system. So maybe that's why it costs more for 2 tickets compared to 3. The next one, this would be like a test. Each question, you're trying to figure out how much each question's worth. 75 divided by 15 would be 5 points a question. 70 divided by 14, 5 points a question. So that seems to be fair. Same amount of points for every question. Most of the time for testing pieces, you want to make sure that you're consistent and fair in how you grade. So I hope that I do that for you. I want to make sure that if you have the same answer as someone else, that I give the same amount of points regardless of who it is. The next one is like fairly obvious. It's not fair just on first glance. If you trade 24 football cards for 15 baseball cards, that's clearly different than trading 20 football cards for 32 baseball cards. So it appears that this is not fair. So just strictly based on the proportions, one's higher than one because it's going to be a bigger number over smaller, and the other one's a small over a larger number. So it seems like this would be an unfair situation. The problem is, what you're not looking into this is, well, what types of cards are you trading? Maybe you're trading a bunch of cards that you don't want for one that you really want, or that's worth more and things like that. So the economics of the situation may change. And that happens a lot of time with any trading or bartering system, is that it may be fair in this specific case, but if you change the dynamic of the question, okay, maybe it becomes still a fair statement. So that's one thing to think about in this situation. Okay, your homework is section 5.2, numbers 15 through 20 and 33 through 37. You need to make sure you support your answers, just not yes or no. So, for example, saying this is not fair or not, don't just write no, it's not fair. You need to make sure you explain somehow, okay, why the answer is fair or why you think it's not fair. Obviously, there's maybe more than one answer to the fairness piece. The book strictly goes through the fact if the proportions aren't equal, then it seems unfair. But you can also explain that in a couple different ways as you're looking at these scenarios. So your homework's from section 5.2, and just make sure that you explain yourself on those questions. Have a good day, everyone.